Hi, my name's Ken Curt. I'm Product Manager for IDT's Signal Integrity product line. Today I'd like to talk about our PCI Express 3.0 Retimer products for high-speed 8 gigabit per second signal conditioning. What I'm showing here is a diagram of a server. Now this diagram shows multiple uses for IDT signal conditioning products, including for SAS, SATA, USB 3, and other protocols. However, in the middle of this picture, with the bright red border, shows our PCI Express Gen 3 Retimer. And in this case, you see it's connected up to IDT's new Enterprise Flash Controller as one example application. Another common application is the use of signal conditioners in blade servers. And this diagram shows the signal conditioner on each of two blades within the chassis. And the purpose of the conditioner is to get this signal across this long backplane, which can be up to 20 inches or even 30 inches of trace when the trace on the blades themselves is considered. So crossing a trace of that long with two connectors in the path is a challenge, especially at 8 gigabit per second PCI Express. And that's the purpose for IDT's Retimer product. In this case, it's shown as the T0816P, which is an 8-lane, 16-channel Retimer. This slide shows the block diagram of our Retimer. Again, the 16-channel device. You can see going from top to bottom the 16 lanes, but at the very top, the interface to the real world, the physical layer interface, begins with the receiver and transmitter equalizers. Below that, you'll see the serializer, deserializer, the SerDes, and below that, you'll see a microcontroller. Each channel of this device has its own microcontroller for coordinating various initialization and power management functions in real time within this device. As we go below the microcontroller, you'll see a routing function that supports simple routing such as lane reversal, polarity swapping, and other simple things like that. It's not a packet switch, of course. Off to the right side of this image, you'll see the two I2C or SM bus ports. There's a master and slave port to give complete flexibility in your system application. And below that, you'll see the configuration vector, which is important to achieving the very low 10 to the minus 12 error rates that PCI Express Gen 3 automatically negotiates to. There's also a JTAG interface, and immediately below that you see the clock. A Retimer device, of course, requires a reference clock input. To hit the highlights of our Gen 3 Retimer, first of all, it's fully PCI Express Gen 3 specification compliant. It's also fully downwards compatible to the 5 gigabit and Gen 2 and 2.5 gigabit Gen 1 specifications. I showed earlier one version of this device, the 16-channel version. We're actually planning for two versions of the product. There's a 16-channel version which will come in a 196-pin BGA package. There's also the 100-pin BGA package, which is footprint compatible with our 4-lane repeater device. So that's a 4-lane Retimer, which is the T0808P version. To go into the rest of the features, there's on the receiver side, the receiver begins with a high sensitivity, of course, high-speed analog CTLE equalizer stage, or continuous linear equalizer, and that's followed by a decision feedback equalizer, a DFE, or a digital equalizer stage. And that exceeds PCI Express Gen 3 specifications and provides the compensation for channel loss and jitter and ISI, or intersymbol interference, that's picked up from vias and other discontinuities, connectors, and things like that in the channel. The transmitter portion of this device, I'm going to break. I need you to go back to the previous slide. Thank you. The transmitter portion of this device includes a 4-tap FIR filter. This also exceeds PCI Express Gen 3 requirements, and its purpose is to support output waveform shaping or pre-compensation of the signal for driving across long traces. Not only can we adjust the transmit amplitude, we can adjust the waveform characteristics or shape, we can adjust the slew rates, as well as the I/O terminations for input and output. So there's tremendous flexibility in the I/O capabilities and configuration of this device. A very important function and unique to PCI Express Gen 3 is the automatic negotiation process for Gen 3 configuration parameters. So the receiver equalizer and the transmitter stage all have to be configured. This is handled by a new procedure or protocol within the PCI Express Gen 3 standard. In addition to the automatic equalization, our device automatically adapts for different rate changes and optimizes for the actual rate of operation. So for example, if someone plugs in a Gen 1 host bus adapter or graphics card, for example, our device will optimize for the 2.5 gigabit per second data rate. Very important at the high 8 gigabit per second performance is automatic calibration. So our retimers automatically calibrate for output skews. They'll calibrate termination impedances and other functions within this device to make the signals and the timing as close to ideal as possible. Of course, at 8 gigabits per second, all these margins become very important. Our device has full support for automatic power saving states, such as the L0S state that Intel's been promoting heavily lately. If the root complex and endpoint device go into a power down state, our device will of course follow that to achieve the lowest overall system power that's possible. Our retimers support either independent clocks or a common spread spectrum clock. So you have multiple options in terms of clocking. Our devices also support hot swapping. And finally, the retimers offer built-in instrumentation capabilities. There's a built-in pattern generator and checker function, as well as an on-die scope capture capability. And this is very important. If you think back to that blade server application where you have retimer parts on 2 blades at each end of the channel, from the transmitter side you can now generate a pattern with the pattern generator function. That pattern can output a signal, and you can adjust the output swing and emphasis characteristics, the slew rate. You've got full control over the output characteristics. Now that signal will then pass down the channel to the receiver. Now if the channel is, or if the receiver is our retimer, you have the ability to capture the input waveform either at the pin or after equalization. And of course you can adjust your receiver characteristics as well, the input equalization as well as the input sensitivity. So now you have the ability to margin your channel to provide optimum margins for operation. Of course, PCI Express Gen 3 can do that all automatically. As part of this instrumentation feature, you can output the data to a Windows-based PC and look at it under a GUI, a user interface that IDT also provides. So it's software accessible. Being software accessible means it's very convenient to debug with in the lab. But also, once the system is deployed in the field, you could conceivably even access the information remotely. via the internet. So a very powerful tool and very powerful capabilities built into this retimer. Okay, so to wrap up the advantages that IDT brings in terms of signal conditioning products, we have best-in-class analog performance. And this is hereditary. It's based on our experience with building high-speed memory buffers, the physical interface of those, built on our experience with PCIe switching and SRIO switching and other devices. So we have excellent skills in the analog domain. We also consider these devices to be server class or server grade signal conditioning devices. And by that we mean that they have lots of configuration capabilities, including the ability for automatic training under PCI Express Gen 3. We wrap around our semiconductor products a full suite of hardware development tools. I'd already mentioned the GUI that we have available. We have the instrumentation capabilities in these devices to make debug and design easy. And finally, we have an excellent support team for our signal integrity products. The engineers are skilled in the unique requirements around signal conditioning and the unique problems that they present within your system. So I'd like to conclude on that note, and thank you for your time and attention.